Hi, this is Mr. Mack. This is a concept video on angles and angle measures. Now, in trigonometry, when we talk about angles, there's an awful lot to this. First of all, let's take a look. What do we mean when we talk about an angle in standard position? Now, if an angle is in standard position, it's placed on the XY axis so that one of the rays is with the aligned with the positive x-axis. We call this the initial side of the angle. Now, the other ray of the angle, the vertex of the angle, of course, will be at the origin. The other ray will be considered the terminal side. So the initial side is where the angle begins, and then it rotates to the terminal side. And then we have a degree measure for this angle. Now, any angle in standard position, the initial side will be on the positive x-axis, and the terminal side will be where it is, and the vertex of the angle will be actually at the origin. Now, we count angles, let's see, this is maybe 60 degrees. We count angles to be positive when we go counterclockwise from the x-axis. See, in other words, we started on the x-axis and we went counterclockwise to the terminal side 60 degrees. So this would be an angle that has a measure of positive 60 degrees. Now we count angles where we go clockwise as negative. So in other words, if we started on the x-axis and we went, say, 54 degrees clockwise, we would consider that to be a negative 54-degree angle. Now, I'm sure that you can see that sometimes we can have angles that have seemingly different measures, but their initial ray and their terminal ray end up at the same spot. For example, if we had an angle that was, say, 420 degrees, it would start, its initial side would be on the positive x-axis, and then we would go counterclockwise. Now we would go 360 degrees to get right back to the x-axis, and then we would go 60 more, and we would end up right where this terminal angle is right here. So an angle of 60 degrees and an angle of 420 degrees are referred to as co-terminal angles. That means that they have their initial rays and their ending rays, terminal rays, at the same spot. Now, if this wasn't complicated enough, we do want to throw another monkey wrench into the system here. A lot of times we don't really like to measure angles in degrees. See, degrees is a scheme where we take the entire circle and we cut it up into 360 parts, and each one of those parts is called a degree. So we know that 90 degrees is 1/4 of a circle, 180 degrees is half a circle, and so on like that. But what we like to do sometimes, and this actually, there is a reason for this. This turns out to be much better when you're doing calculus. What we like to do is we like to say, all right, if we have a circle that has a radius of 1, see now, if it, and its center is at the origin, then this point right here would be the point 10, this point would be the point 01, and so on like that. Then if we had an angle, let's say, for example, we have an angle of 30 degrees here, we would also like to be able to tell you the measure of the angle by the arc length that that angle would cut off on a circle with a radius of 1. Now, a circle with a radius of 1 is ordinarily referred to as the unit circle. And it's pretty easy to see how we could figure that out. See, 30 degrees is 30/360ths of a complete circle. And if we multiply that by the circumference of a circle with radius 1, 30 over 360 becomes, what does that become? It becomes 1/12. So we get 1/12 times 2 pi put that over 1. 12 will cancel, leaving 6. So we get pi over 6. Now we would say then that 30 degrees is equivalent to pi over 6 radians. Now, the easiest thing to remember is that radian measure is the length of arc on the unit circle that a degreed angle would cut off. So 30 degrees would be the same as pi over 6 radians. 45 degrees, for example, turns out to be pi over 4 radians, and 60 degrees turns out to be pi over 3 radians. 90 degrees, of course, is pi over 2 radians. And so basically, what does this mean? Well, it means this. If you have a degree measure, if you want to change it to radian measure, you multiply by 2 pi over 360. See, because the 360s will cancel with the degree measure, and then the 2 pi will turn it into radians. So imagine we had a 10 degree angle and we wanted to know what it was in radians. Well, 10 degrees times, oh, and by the way, 2 pi over 360 reduces to pi over 180. So we just usually use pi over 180. Turns out to be pi over 18. So pi over 18 radians is the same as an angle of 10 degrees. Now, let's say we had an angle of pi over 5 radians, and we wanted to convert it to degrees. Well, we would multiply by 180 over pi. In other words, the reciprocal of pi over 180. And the pi's would cross cancel. We'd get 180 over 5, which becomes 36. So pi over 5 radians is the same as a 36 degree angle. Okay, now one more thing that, and this really makes radians kind of useful right now. If we have a circle with a radius, I also need to mention this. If we have an angle that has its vertex at the center of the circle, then we call it a central angle. Now, if you have a central angle with a radius and let's say some measure, you can find the measure of the arc length with the simple formula. R theta is equal to S, as long as theta, of course, is in radians. So if we wanted to know, for example, we've got a circle, and let's say we have a central angle of pi over 8 radians, and let's say the radius is 16, and we want to know the length of this arc. Well, let's call it S. S would simply be equal to 16 times pi over 8, or 2 pi would be the length of that particular arc length. So we can use radian measure very easily to find arc length on a circle of any radius by the formula S, arc length, is equal to R times theta. And that is the basic information that you're going to need to know to do problems in Chapter 13, Section 2. So we're done.